Hi everyone, we're going to work on how to solve and graph inequalities today. So the nice part about this lesson is we are taking everything that we've learned so far from equations, all of our multi-step equations, including those with variables on both sides, and we're going to apply it to inequalities. So it's a great way for us to get more practice and you to see more examples so you can feel confident in solving both equations and inequalities. All right, our first question here, we are being told to first solve the inequality and then graph the solution. So remember, when we're working with both equations and inequalities, our goal is to get our variable by itself. So we can determine, in this case, what the value is for A. What does A represent? So because this problem's a little bit shorter, I don't have too many things going on, it's going to be a little bit quicker to solve. But one thing I like to do, and I'm going to do this in every single problem, is I like to draw a line straight down from either my equal sign or my inequality sign, because it kind of helps me separate the two sides. It helps me determine what I need to do first, and it ensures that whatever I do to one side, I also do to the other, so I can keep that inequality balanced. I can keep this a true statement, so it truly is an equivalent and an equal answer. All right, in order for our variable A to be by itself, we're going to have to get rid of both that 9 and that 6. So in order to figure out what we need to do first, remember our theme for inequalities and equations is the inverse, the opposite. So we're going to do the opposite of what's being done to the A, and we're going to do it in the opposite order. So reverse order of operations, reverse PEMDAS. Meaning the first thing we need to do is get rid of anything that's being added or subtracted. And in this case, we have a -9. Well, the opposite of a negative is a positive. And remember, positive and addition is one and the same. So we're going to add 9 to both sides of our equation. And the reason that inverse works is because it cancels it out. -9 plus 9, or a -9 and a +9, when they're combined, they equal 0. So that zeroes it out on the left and moves it on over to the right. So we're just left with, don't forget this sign here, a minus, or a -6a is less than 9 plus 9, which would be 18. All right, now with what we have next is we have that -6 or that -6, you can say it either way, is being multiplied by A. So because multiplication is the operation that's occurring between the number and the variable, that's what we're going to do the inverse of. So the inverse, the opposite of multiplication, would be division. So we're going to divide both sides by that -6. And a negative divided by a negative would cancel out and become a positive. And a -6 divided by a -6 would be a +1. So we're left with one single A. And then remember, when you're dealing with inequalities, if you multiply or divide by a negative, you have to flip your inequality symbol, because that negative is saying, hold up, it's the opposite. So we need the opposite symbol, turning it to greater than. And then we're going to get a decimal answer here, but that's okay. 18. Oh, no, we're not. I was not thinking straight, sorry. We have 18 divided by -6, which will result in a -3. So we have now solved our inequality. A is greater than -3. When we go to graph that, remember, if you have a greater than or a less than symbol, that is represented with an open circle, because it means that specific number, in this case -3, isn't included. A can only be equal to numbers that are greater than -3, not -3 itself. But if we had an inequality symbol that was greater than or equal to, or less than or equal to, that's represented with a closed or a filled in circle, because that's telling us that could be equal to that number. Therefore, that number is included. All right, in this case, because A is greater than -3, we're going to have an open circle at -3. And then A is greater than. It's all of the numbers that are greater than -3, which means it's going to go to the right, because all of those numbers to the right are greater, they are larger than -3. And there we have our graphed solution. All right, now that we've done a problem together to kind of review and refresh our memory, on this next problem, I want you to pause the video and try to solve it yourself. Then you can hit play and compare my work to yours so you can see if you got it correct. I really want you guys to do this because, especially with equations, since there's so many steps, really the only way to feel confident and get good at it is by practicing. And this is a completely safe zone because you're watching the video and you're able to hit pause along the way if you need to. But please, please, please hit pause. Try to solve this inequality yourself, and then come back and watch me go through the solution and see if you got it correct. All right, so now that you've had a chance to solve this yourself, let's check our work here. We have the inequality v over 2 plus 10 is less than or equal to 9. So I'm going to start off by drawing a line here to separate my two sides of the inequality. And I can see I'm trying to get v by itself. And the only things going on is it's being divided by 2 and we're adding 10. So in that theme of inverse, we need to do everything in that inverse and that opposite order. So reverse order of operations, we're going to get rid of any addition or subtraction first. The inverse of adding 10 would be subtracting 10. We're going to subtract 10 from both sides. 10 minus 10 is 0. That zeroes out, and we're left with v over 2 is less than or equal to 9 minus 10. Ooh, great opportunity to practice our integers here. If we write it out long ways, we have 9 minus 10. One way you can think about this is you're subtracting 10. You're taking 10 away, which is more than 9. So you're taking away more than you started with, resulting in an answer of -1, because 10 minus 9 is 1. But because you're taking away more than you had to begin with, we have a -1. Another way you can look at this is by simply just following the rules and writing out every step. Whenever you have a subtraction problem, you can rewrite it as adding the opposite, because subtracting is the same thing as adding the opposite. So we can rewrite this as 9 plus -10. And when you're adding integers, if the signs are the same, you add them and keep the sign the same. If the signs are different, you subtract and keep the sign of the heavier number. So in this case, our signs are different. So we would subtract, giving us 1. And then the heavier number would be 10, because there's more 10s than there are 9s, resulting in a -1. All right, so either way you want to look at it, 9 minus 10 is -1. All right, back to our problem here. So we have v over 2, but remember another way we can say that is v divided by 2, because fractions represent division. So the inverse, the opposite of division, would be multiplication. So we'll multiply both sides by 2, and that cancels out, giving us v is less than or equal to -1 times 2, which would be a -2. Why did I not flip my inequality sign this time? The reason why is it's not whether your answer is positive or negative, it's whether you're multiplying or dividing by a negative number. And the number that I multiplied by was a +2. So because I multiplied by a positive number, my inequality sign stays intact and it stays the way it is. So our solution here, our answer is v is less than or equal to -2. Now to graph the solution, because it's an or equal to inequality, that means I'm going to have a solid or a filled in circle. And if v is less than or equal to -2, well, the numbers that are less than that are farther away from 0, so our line is going to go to the left. All right, next up, we have the problem 14 is greater than 2 times the quantity of z plus 11. All right, once again, I want you to pause the video, try to solve this on your own, and then come back and hit play and compare your work with mine and see if you got it right. All right, that's the best way for us to learn. All right, with this problem here, there are 2 different ways that you can solve it. Because there are parentheses, that means I got to get rid of those parentheses first. I could get rid of them by distributing, or I could get rid of them by dividing, because remember that distributive property is multiplication, and the inverse of multiplication is division. I'm going to choose to solve this by dividing, but if you chose to use the distributive property, that's fine. You should still have gotten the same answer, okay? Oh, I see that these parentheses are here. That's kind of messing up my normal order of things, adding and subtracting before multiplying and dividing. We always have to get rid of any barriers first, do any simplifying first before we can get to the actual solving. So because these parentheses mean multiplication, the inverse of multiplication is division. So we're going to start off and divide both sides by 2. 14 divided by 2 is 7. Bring down the inequality sign. 2 divided by 2 is 1. So once that goes away, there's no reason for the parentheses to be there because that multiplication has been cleared, and we're left with z plus 11. All right, now how do we get z by itself? We need to get rid of that plus 11. So the opposite of a positive or adding 11 would be subtracting. So we're going to subtract 11 from both sides. 7 minus 11. Remember, one way you can think about this is you're taking 11 away, and that's more than 7. So our answer is going to be negative, leaving us with a -4 is greater than z. All right, so this is a completely acceptable way to write your answer. But because I have to graph it, I do better when I'm graphing if my variable is first. So I'm going to rewrite this so my variable is first. Just be careful that when basically we're flipping this inequality around, we flip everything around, including our inequality sign. So I'm going to flip the z over to the other side, flip my inequality. Oops, that didn't write proper. There we go. And then flip the -4 over to the other side. And a great way that we can make sure it's correct is kind of going back to like elementary school when we first learned about inequalities. Your teacher maybe has compared it to alligators or to Pac-Man, and it's always eating the larger number. So if we look here, our inequality is opening towards and is eating the -4. And when I flipped everything around, it continues to do so. It's opening towards, it's eating that -4. So that means I flipped it properly and can, feel confident that my graph will be accurate. So because z is just less than -4, we would have an open circle at -4. And if it's less than, it's the numbers that are smaller, so farther away from 0, meaning our answer and our line is going to go to the left. So z is less than -4. All right, so on that last problem, we chose to get rid of our parentheses by dividing out instead of using the distributive property. That worked on the last problem, because if we go back to it real quick, there is nothing else going on. We don't have anything extra that we need to do. We don't have anything extra to simplify. But if we now look at this new problem here, notice that we have both parentheses and we have something extra. So when that happens, we have to use the distributive property. We have too much stuff going on. It's not going to work for us to divide because there's other stuff there. All right, so this case up here only works when it's literally just the distributive property. So it may be a method you choose to use. Maybe you decide to just always use the distributive property because you know that works 100% of the time. Personal preference, up to you. All right, now that we're getting into larger problems, this is where, if you want, you can use that mnemonic, that little acronym, don't call me after midnight, to make sure that you do the steps in the right order. So the don't call me after midnight really is just a way to say, hey, simplify the problem first, then you can solve it. So if we do that little mnemonic here off to the side, I'll just write the generic steps. So don't call me after midnight. The D in the acronym, it stands for distribute. So remember, to know whether or not you need to distribute, you're looking for those parentheses. And I, in fact, have those parentheses here. So that means I do need to complete that first step. I need to distribute in order to get those parentheses out of that picture and help me simplify this first so I can solve it. So with the distributive property, remember that -4 is being multiplied by everything inside the parentheses. So we're going to distribute that -4 into everything. So -4 times 2 would be -8. And then -4 times 3 would be -12. So we either could write this as plus a -12, or you could simply write it as -12. We'll go ahead and write it as plus a -12. And then everything else stays the same. Bring it on down, because we only distribute to what's inside the parentheses. Our next step, our C here, stands for combining like terms. And when we're looking to see if we need to combine like terms, we're focusing on either side of the inequality. So that's where that line there can help you. So if I look at the left, I'm looking to see, do I have any like terms? And I do. I have a -12b and a 5b. They're like terms because they both have the same variable. So I'm going to go ahead and combine those. Oops, I forgot to check off our first step. We distributed. Now let's combine like terms. So -12 plus 5. Remember, when you're adding and the signs have numbers have different signs, we have a -12 and a +5. Because the signs are different, we're technically subtracting, and then you keep the sign of the heavier number. So 12 minus 5 is 7. 12 is heavier, there's more 12s, so it would be a -7b. And then we're going to bring everything else down. And we don't have any other like terms to combine because our 8 or a -8 and our 13 are on opposite sides of the inequality. They're on opposite sides of that line, so I can't combine them right now. Our next step is whether or not we need to move the variable. Well, I only have one variable now. I just have my variable term of a -7b. There's no other variables anywhere else. We don't need to do that step, which means now we're left to what we've been seeing up until this point: add or subtract, then multiply or divide. So in this case, do we need to subtract or add? We need to add because we have a -8. So the opposite of a negative would be a positive, which is meaning we're going to add 8 to both sides. So -8 plus 8 is 0. That zeroes out. And we're left with -7b is less than 13 plus 8, which is 21. And then our final step here, last but not least, is to multiply or divide. So we have -7 times b. The inverse of multiplication is division. We're going to divide both sides by -7. -7 divided by -7 is 1. So we're left with one single b. Because we're dividing by a negative, Remember that flips our inequality sign, making it greater than, and 21 divided by -7 would be a -3. All right, let's quickly graph that. We have an open circle at 3, and because b is greater than -3, all those greater numbers are to the right, so we've graphed our solution. All right, next problem here. Just like before, please pause this video, try this problem yourself, and then hit play and see if you got it right. And if not, at least it's a good learning process for you, so you can see how far you were able to get before you got stuck, and that'll kind of help you know where you're having issues and what you need to really listen in for or email me about to see, where we're still getting stuck with things. All right, I've already listed my little acronym off to the side so I can check things off. Don't call me after midnight. I'm going to draw my line through my inequality here to keep my sides separate. I'm set up and ready to go. First thing is, do we need to distribute? So remember, if we have to distribute, we're going to have parentheses. I don't see any parentheses. Nope, don't need to do it. Do we need to combine like terms? Well, remember, when you're combining like terms, you're focusing on either side of the inequality. So on the left here, all I have is a -5y. No like terms there. If I look at the right, I have a -7y and an 8. Those are not like terms. One has a y, one doesn't. So I don't have any like terms to combine either. Do I need to move the variable? Yes, this is where it comes into play, because we have a variable here on the left and a variable here on the right. So we need to move it to get the variables together. Now, it does not matter which variable we move. I'm a creature of habit, so 9 times out of 10, I'm going to move the variable on the right over to the left, just because I like it when my variable's on the left. But it technically doesn't matter. There's every once in a while I'll do it differently, but usually I just move in that direction. But please note, that's not a requirement. You can move either one. It technically doesn't matter. So we are going to move our variable, and because we're moving to the other side, that means we need to do the inverse. Whenever we cross that line, we have to do the inverse. So the inverse of a -7y would be a positive. So we're going to add 7y to both sides. -5 plus 7. Because their signs are different, we subtract and keep the sign of the heavier number, giving us a +2y is less than +8. And because it was a +8, I don't have to write that plus sign there anymore, because when nothing's there, that just automatically means positive. All right, next up is, do I need to do any addition or subtraction? Nope, nothing is being added or subtracted to our y. We can skip that step. So now multiplication or division? Yes, sirree. We have 2 times y. So we're going to divide both sides by 2. It's a positive number that I'm dividing by, so my inequality stays the same, and y is less than 4. So when we go to graph that, open circle, y is less than 4. That means we're going to the left. Leftaroo. All right, we have one more problem like this before we get into the second and final topic of today's video. So just like before, please pause the video, try to solve this on your own, even if you were unsuccessful before. Every time you try, and then compare your successes and your mistakes to, my work that we do together. It's going to help you learn. It's going to help you make that progress, okay? All right, pause and work this out yourself. All right, hopefully you feel good about what you did. If not, no worries. That's what I'm here for, to help you learn. So our little acronym here, if you like to use that, help keep us organized. I love the little checklist aspect of it. Don't call me after midnight. All right, remember that the D stands for distribute, so we're looking to see if we have any parentheses. Do we have any parentheses? Nope. We can skip that step. Combine like terms. Well, when I look on the left here, I have an H term. So I have a variable term and a constant. Nope, can't combine any like terms there. How about on the right? Same, nothing there that we can combine. All right, so that means we can't combine any like terms. Do we need to move the variable? Yes, we do have a variable on either side, so we need to move that to get them together. When we move our variable, because we're moving to the other side, we must do the inverse. So the inverse of a negative 7h would be adding 7h to both sides. All right, we have a negative and a positive. When the signs are different, you technically subtract and keep the sign of the heavier number, leaving us with a negative 3h plus 1 is greater than or equal to 10. Do we need to add or subtract? We do. We have a plus 1 being added to that h, so the inverse would be subtraction, leaving us with negative 3h is greater than or equal to 9. Last but not least, we must multiply or divide. We're going to divide both sides by negative 3. Negative 3 divided by negative 3 is a positive 1. Because we're dividing by a negative, inequality sign flips. 9 divided by negative 3 would be negative 3. So h is less than or equal to negative 3. When we go to graph that, solid circle to the left. All right, nice work. All right, the last topic that we're going to practice on here is taking a graphed inequality and writing the inequality that goes with it. So we want to know what inequality this number line shows. When we do this, it doesn't matter what variable you use, because as you know, throughout the video, we use different letters, we use different variables. Just because X is kind of the most common, I usually use X, so we know that we're going to have X and then our inequality symbol and a number. And in this case, the number that our point is on is a negative 167. And then if it is filled in, because it's a closed circle, it's either going to be less than or equal to or greater than or equal to. So let's check out the way that our line is going. Our line is going to the right. That means it's going towards 0. It is going towards the greater numbers. So if X is greater, the alligator eats the greater number. Here is our greater than symbol. This would be the inequality statement that matches our inequality graph here. All right, for the second one, same process here. We have our variable and then the number that our point is on, which would be a 3. Because it's an open circle, it's either going to be a regular less than or a regular greater than. Because this line is going to the left, it's going towards the smaller numbers. That means X is less than. X is smaller than 3. X is less than 3. All right, final 2 problems here. I want you to pause this video one more time, see if you can answer both of these questions, and then compare your answer to what I have. All right, for our first graph here in blue, we have X, and then we have the number that it's graphed on, which would be 4. We see that it's an open circle, meaning it is either going to be less than or greater than. Because our arrow is going to the left, it's going to the numbers that are smaller, that are less than 4. That means X is less than 4. And remember, it always eats the larger number, so it's going to be opening towards the 4 because X is less than 4. For our second one here, we have our variable and then the number that our graph is on. It's on the number 3. It's a closed circle, meaning it's either going to be greater than or equal to or less than or equal to. Because it is going to the right, that's where the larger numbers are, or the greater than numbers. So x is greater than or equal to +3. All right, I hope that this video helped you out, hopefully by you doing some practice problems and being able to very quickly and immediately check your work and compare what you've done. You have a better understanding of solving these multi-step inequalities as well with how to graph them and write the graph if you're given one. If you need anything, make sure to send me an email. Bye.